So today we're solving radical equations, and we're going to use these 4 steps to solve each one. First, we'll isolate the radical. That means we're going to get the part of the equation underneath this symbol, the radical symbol, on its own. Then we're going to eliminate the radical by raising both sides to a power. Then we'll solve and check our work. So let's take a look at these one-step equations. My first one says the square root of x is equal to 10. And I don't have an index written here, but I know it's a 2. So I'm going to write that 2. The reason is that when I see that 2, I know that if I want to eliminate the radical, the way to do that is going to be to raise both sides to the power of 2. That will eliminate that radical. And when I do that, I get x is equal to 10 times 10. So x equals 100. That looks like that's my answer. Let me just check my work here. Is the square root of 100 equal to 10? Yes, it is. So x equals 100. Now, some of you may be thinking, hang on a minute, the square root of 100 could also equal negative 10, right? Sure, it could. But when we're solving radical equations, we're only talking about the positive square root. We don't look at the negative. Why not, you ask? Well, here's the answer to that. If you were to graph the square root function, it would look something like this. That's if you only graph the positive square roots. If you were to graph the negative square roots also, it would look like that, and that would not be a function. So we're only talking about our positive square root values when we solve our radical equations. Let's look at another square root over here. The square root of n is equal to 9. Again, my index is 2, which tells me that I'm going to be raising both sides of my equation to the power of 2. So in this case, I get n equals 9 times 9, which is 81. Is the square root of 81 equal to 9? Yes, yes it is. So I know that 81 is my answer. Now what if I had a cube root like I do here? So in this case, my index is written for me. It's a 3. So I'm going to be raising both sides to the power of 3. That gives me y equals negative 3 times negative 3 times negative 3, which is negative 27. Let's check that out and see if it works. Is the cube root of negative 27 equal to negative 3? Yes, it is. And we can have negative cube roots because the cube root function is already a one-to-one function without any restrictions on its domain or range. So here we have y equals negative 27. What about a fourth root equation? This one says that the fourth root of w is equal to 2. So let's use the same procedure, just this time we'll raise both sides to the power of 4. That gives us w equals 2 times 2 times 2 times 2, which is 16. So w equals 16. Is the fourth root of 16 equal to 2? Yes, it sure is. And we are not going to think about the negative fourth root of 16. We're going to ignore negative 2 because, again, we're only going to look at the positive values here for our fourth root. So w equals 16 is the solution to this equation. So in summary, to solve these one-step equations, what we did was we looked at our radical. If we had a square root, we raised both sides to the power of 2. If we had a cube root, we raised both sides to the power of 3. If we had a fourth root, we raised both sides to the power of 4. So there's your summary on one-step radical equations.